What's up? What's up? Welcome back. Today we're working on my operating system. It's an x86 operating system titled StreamOS. It's an operating system that we're kind of writing for fun / learning, trying to get like a better intuition about how operating systems work. And we're kind of just like implementing whatever we need to do to accomplish whatever we feel like doing. And what that is at this point is we're trying to play Doom in our operating system. So let me just pop open a demo real quick. Let me just pop open my development environment. I think I forgot to set this up before stream started, so just give me 2 seconds. Boom, 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 boom. Just gotta wait for it to start up. There we go. Let me just make sure that we committed everything from last time. So we'll say this is from end of stream on November 22nd. And let's check out our master branch and give a quick little demo. So what we're doing here is we're building our kernel. Oops, sorry, just 1 second. Forgot to store some environment stuff. We're building our kernel, and it's going to launch in a virtual machine called QEMU. And this is like the operating system as we know it today. So it has like keyboard support, mouse support. We're like rendering this like game to the screen. And in parallel, we're running like this web server, so we can go over here and say like hello, hello, and it'll like send us stuff back. It's like logging to us through serial, which QEMU, the virtual machine, very like helpfully forwards to us as like just standard input output. And we have some like proof that we're like doing some interesting stuff like talking to the Ethernet card and talking to the clock and like doing memory allocation and stuff like that, as well as like multi-core. We're doing like CPU1, CPU3, servicing stuff where it needs to get serviced. Yeah, so that's where we're at right now. And what we're working on is trying to get Doom to run. So what we did last stream was we got to the point where we pulled in this project, Doom Generic, which is this like a version of an open source Doom engine that is kind of built for porting, because like, you know, it's like a big meme to port Doom to whatever, which is why we're doing this in the first place. And its promise is you implement a few functions and everything works. So what we've got so far is like when we pulled this in, we found out that we're missing a lot of like standard library functions, right? So if you try to call like printf, like we have to implement that for that to work. So we kind of went through one by one and we fixed up all of the different cases of it trying to use the standard library that we had run into until we got to here. So we've implemented kind of like this like draw frame by just copy pasting what they render into like our frame buffer. We've implemented like a little bit of like time, but other than that, we haven't really done anything. So we can't like play this game at all, right? I like slam on my keyboard and nothing happens. But we do have like proof that the engine is kind of working correctly. And so what we want to do today is like actually get playing, right? So implement any like keyboard control and then kind of figure out there's like other things that like we haven't implemented yet that might come up when we actually start playing, right? If that's just like a pre-recorded video, then we might not be hitting all of the edge cases. So hold on, just let me pull open here. Like if I go into our libc implementation, there's a lot of stuff in here that we still haven't implemented, right? We haven't implemented like fabs, and I'm surprised that that isn't causing problems right now. So that's what we're going to work on first. Is we're going to work on getting like keyboard control set up. We also spent a lot of time leading up to this implementing mouse control. And so I think that the Doom generic source code doesn't support mouse as is. So we're going to have to maybe like take a quick look to see if we can implement that. Otherwise, it'll be hard to control. And yeah, we'll just kind of see where we get. So the first thing to do would be to implement dg get key. And so let's just look at that. So Doom generic, in its README, it says, I should implement dg get key to provide keyboard events. And so let's look at like an example of one of their ports to like Linux. So we can look at like Doom generic xlib. And this can tell us like, oh, here's what they expect to see. So they take in a key, they reassign it, and they return it. And so they're basically converting from xlib keys, like X Window System key presses, into keys for that are probably defined in like the Doom generic source code. And here they add key to this, like they add the key to the queue, and then probably when they get the key, they read the key from the queue and then do some like shifting of stuff. Okay, so it looks like they're also expecting like a return 1 on success and a return 0 on nothing to do. So let's maybe take a look at who calls DG get key. Who calls this? None of these guys are looking for this guy. Okay. So while this guy returns non-zero, he updates shift status. Okay, which was what? If key equals key, right shift. Okay, sure. Change is equal to 1 or -1, depending. And here he assign equals shift down, which is like, I guess, a global variable. Is the shift key currently down? Sure. Okay, so I see. So they check if right shift is pressed and update their global state. Cool. Nothing too interesting there. Then they check if a key was pressed. And if it was, they do some like translation. Otherwise, it was not pressed, it was released, and they do some other translation. And it looks like they had some like mouse support code that they stubbed out. So that'll be useful later. Okay, so where is this translate key? He does nothing. Okay. It would be nice to find like these definitions that they were using of like key up, key down. It would be also be interesting to know what is this getting. So pressed, I guess, is just 0 or 1. It looks like is what they're expecting here, right? They're looking for, or 0 or non-zero is really all they care about. So it looks like maybe the X loop implementation was just packing that into the data. And then the key is just a character, like a 8-bit character. So where is this like defined? These must be here. No, these where key escape. Like where is this guy set? He must be in a header somewhere. Doom keys. Here is what we're looking for. Okay. So this is the definitions that we're looking for. I see. And so I guess we just want to go through each of these and convert them from like our key codes in our operating system. Okay. So we can go into our code. Hello, hello. What's up? And we can start implementing DG, what was it? Get key? DG get key. Whose function is like this, and we'll just quickly convert him. So this is the function. Pressed is a pointer to an I32, and doom key is a pointer to an unsigned car, which is a U8 in our world, and it returns an I32. Okay. And these actually are mutable because these are out parameters. And for now, we'll just return nothing. But what would be nice is to like check if something was pressed. And here's where it gets kind of interesting. So let's look at our keyboard driver. I actually don't remember how this works. So our keyboard driver in our operating system uses PS2, which is this like old ass port that is basically like a serial device. And basically he looks for scan codes to come in, and that's it. So we just like read the data that comes in on that port, and we say like, what number is it essentially? And I think that this guy was written with async in mind. So it looks like he has like a read function that just waits for a key to be pressed. And that's kind of it. So this poll read feature, I guess, is probably waiting for something to happen. Yeah, so he waits for the status to change on... yeah, I guess it just waits for like a status register to change. When it's set, then it reads the key that we pressed. So what's kind of odd here is that like our implementation of DG get key isn't in like async code, and we haven't even like set up anything async at all. So I wonder how we want to handle this. I guess we could set up the Doom code as a feature that will just run on one core and will never return. And then maybe we can like do something else in parallel on another core. And that core can just like pull this read. Or maybe we might not need an executor to handle this actually. We might be able to say like, let read future is equal to, we need to get our like reference to the static kernel. So let's just get a reference to our driver really quick. PS2 is the best port ever made. You can break pins just watching it. Oh, did they break a lot? I feel like I remember having a PS2 keyboard and I don't ever remember it being like problematic. But maybe I didn't unplug it that much. Okay. So let's just try getting like a reference. You broke a lot of them. all right. I can see it. So I guess on each call to this guy, we might want to like hold on to a future over time. So maybe we want like a static. We'll figure this out in a second. Let's just see how to get a reference to this guy. So is my language server set up? Am I in the right context? Yeah, it is. So I should be able to say kernel nice dot ps2 dot read. And this will give me like a future. And I can like check this future to see if anything's happened. And if it hasn't, that should be okay. So I think I should just be able to call like, if I pin this, let read fut pinned, I should be able to call, what's this called? Core pin read fut. And maybe I'll just rename this like this. And I think maybe I have to say this is mutable. And if I say read fut.poll, I think I should be able to just check if something's happened. I remember learning how all of that working. I would think for some companies, for a while, some companies made PS2 keyboards due to them having lower latency compared to USB. I could see that actually, because the implementation of the driver of this guy is like interrupt based. When I press the button, like an interrupt fires on my PC like immediately. And USB from our USB implementation looked like it had like a maximum or like a minimum latency of like 1 millisecond. Because you're supposed to poll once per millisecond. And so I could totally see that being true. But I kind of figured that I must not understand something on the USB side correctly. Because we use USB gaming mice now. And I find it hard to believe that like people wouldn't care about 1 millisecond latency for like super competitive shooters. But who knows? Okay, so let's try to pull this guy, and he's obviously gonna bitch because it doesn't work. Let's export my cross compiler. I forgot to do that, and let's just kind of see what we see. So we look for an error. He complains that we don't have the future trait, which makes sense. So we'll just use the future trait somewhere. Future, and so now we should have this poll method available. And now we have to pass in a context. So I guess we have to make a context. And how do I do that? From waker, I guess, and we pass in a waker. And so that means we need a waker. Which means that we need to create that. And in our case, our waker is going to do nothing. Because we're not actually ever planning on polling this again. I think that we can get away with just calling this feature one time, like right now, and then dropping it if it isn't ready. So, which means that I think that our waker can just be bullshit. So how do I create a waker again? Waker is in Rust, standard library. And how do we like create one? We have to make a raw waker first. Okay. Which we create a raw waker vtable. Here we go, this is what I'm looking for. So let raw waker vtable is equal to raw waker vtable new, and then we pass in this shit. And all of these guys are just gonna do nothing, I think. Okay. So I think this is static raw waker vtable. And he's gonna be a raw waker vtable. And he's gonna need to take in some functions that have these APIs. So we'll just check this here. I think I've actually done this before, and in like the future stuff way back, but I think I lost it, so I think we have to do it again. So this is an unsafe function clone, and he takes in data and returns raw waker. So we'll figure that out in a second. This is unsafe function wake, and he takes in data and returns nothing. This is unsafe function wake by ref, and he takes in data and does nothing. And drop, I guess we can just say null future function and do nothing and just pass this to all three. And so all I have to figure out is clone. So clone must just say raw waker. I guess we'll make our vtable up here. And we'll just pass in clone, null future function, null future function, null future function. Nothing's going to happen because we're not actually trying to do anything here. We're just trying to get the API to work. Raw waker vtable can be const instead of static. That seems reasonable. I think that's true. And then in clone, we need to make the raw waker, which is the same thing we're trying to do here. So we have raw waker, which we need to import. We construct this guy with core pointer null, right? We have data, but we're not actually going to do anything with that data. And then we pass in raw waker vtable. And then this guy is the same thing. And then we need let waker is equal to waker from raw waker. Ooh, what a pain. But I think we're good to go. And now we can pass the context. I think this has to be mutable, and so we press and mute, I think. Cool. And so we can say, let's see if this read feature is ready. And we can say, if we got something, we will get poll ready, and we'll return the value. And if we get poll pending, we can just return 0, like nothing happened. So I guess return, let's double check what the xlib implementation did. So in Doom generic xlib, they return 0 if the key is empty. So yeah, we just return 0. Nothing has happened. No key has been pressed. And then we say here, let scan code is equal to this. And then all we all have to do later here is match scan codes to keys. So we'll say rest is equal to 1. And doom key is equal to match scan code, and we'll just return. We'll have to figure out what to do later here. Yeah, that seems reasonable. That seems reasonable. So maybe now all we have to do is maybe we should like log our scan codes, and we can just start like stubbing out what they should be. So we'll say got scan code this, and we'll print out the scan code. And then we'll just press buttons and see what they match up with. I think that that'll be all we need. So let's see where it's complaining. So it doesn't like that scan code could not be formatted with the default formatter because it doesn't think that it's a number for some reason. So what's going on there? Yeah, so he thinks that this is nothing. So why is that? What's V here? V is a U8. So shouldn't this think that it's a U8? Like, why doesn't this work? Let's see. Let's start checking in. Watching all this really makes me want to make a custom kernel again. I'm getting into laptop. I'm getting my laptop back tomorrow, so I might look into picking that exact project back up again. Yeah, it's pretty fun. It's really like, there's something really, what's the right word? Like satisfying or like calming, I guess, about it. You just kind of, you know, there's so much progress to make so quickly for something that's so new. And so, and it's really satisfying when you get it to work. So it's pretty cool. Cool. Okay, so he doesn't like that kernel is an ampersand reference, but it needs to be an ampersand mute. So I think I can just say here, get mute. And I think this guy needs to be mutable as well. And then I think now this will work. Let's see. Yeah, so that compiles. And so now we can probably just start like pressing keys and seeing what happens. So actually it still doesn't like that. What's it complaining about now? We have duplicate definition of DG get key because we had our dummy implementation over here, so we'll just delete that. Easy. And come on. I guess compiling in release mode is just going to make my compile times longer for no real major benefit right now, so I'll just sub that out. All right, so we're launching Doom, and if I press a button, so pressing it gives me 28, releasing gets me 156. And I guess maybe I should just start, I should probably write down a bunch of these at once so that I don't have to do this over and over again. So I guess I'll write them over here. So let's press enter is 28, 156. And we'll probably want up. Oh, oopsies, I'm pressing the wrong window. Up is 72. Oh, it's kind of two numbers. 224, 72. Oh, I think I read somewhere that they're like composite scan codes. So when I press up and down, I think that I'm probably getting like 224 for something. Let's see if we can look up that again. So under PS2 scan codes, OS dev maybe is where I saw this. Special bytes. No, that's not what I'm looking for. There were like scan code sets. Here we go. Yeah. Scan code sets. And I think I'm using scan code set 1. Which probably means that I actually don't need to manually press these buttons at all. Let's look at like this. So enter press is 1C, which is, I got 28. So 1C is 16 plus 10, 11, 12, which is 28. Nice. And let's look for like, let's see, up arrow. Is up arrow in this scan code list? Up. E048. So that's probably what we're seeing. Assuming that by cursor they mean the arrow keys. We can probably dodge this by just not using up, down, left, right. I don't really want to handle composite keys right now, so we'll just use WASDA instead. And I guess we'll just, instead of pressing them one by one, we'll just use this table. Is there like a conversion from press to release? It does look like they just have those scan codes manually here as well. Okay. All right. Cool. What did I do in my like game class? Here I see. I like checked for down and up presses, and then as I like kept those in my head. So I guess that we probably have to do the same thing here. We'll see though. I'm assuming that in Doom generic, what was it? Doom I input or something? Like, do they hold the state? Are they looking for key events like press and release? Or are they looking for key state? And it looks like they're looking for key events, which is sick. So I don't have to do any state management on my side. So here, I actually shouldn't be unconditionally setting press to 1 here. It depends on what key I get. So let's start with just enter. So 0x1c, we go pressed is equal to 1. And the key is, where did these come from? Doom keys.h. Key enter. Which is 13. So Doom key is equal to 18. No, why am I saying 18? 13. Okay. And on release, we're going to say 0x9c. This is press equals 0. Doom key is 13. Okay. Cool. And let's see. Uh-oh. Error. Because I didn't match everything. So in here, we'll just do nothing. If for any other case. Is that just top bit is 0 and press and 1 release? That seems like very likely. I noticed that as well, but I wasn't sure, so I didn't say it. But you're right. I think there's a good chance. Okay, so we press enter now. Stuff happens. We're in the game. And now we just have to implement some other stuff. Cool. Cool. So I guess we'll just copy paste these guys. These are the important ones probably. And we'll just kind of stick them here in a block, in a comment, just so that we have them written down. And really, it's kind of silly to do it this way. I should probably be using these by name. So we'll just quickly say, delete this, turn it into a const. This is now going to be a U8. And he's equal to the value here. And we'll do that a few times. And we'll preface this with Doom, so that we know where we're going. And did I already define scan code somewhere? Input keyboard A up. I do have these written down somewhere, so let's kind of just pull these guys in as well. And start matching them. So we'll say W down goes to pressed is 1, Doom key is equal to Doom key up arrow. W up goes to do pressed is the same thing, but press is 0. And now we replace W down with A down, and we move to the right. Like this. And we do the same thing for D, but this is down arrow. And almost certainly, I don't know, you could argue that there's a lot of duplication going on here. And I would agree, but the question is, is there like a better way to structure this? You could maybe like do it with a macro in some way, right? Like generate this switch case. You could also do it with like a jump table by like dropping all of this into a like a vector that you like you specify with a scan code and that like automatically maps. But I think this is like fine. I don't know why I thought A was right, so let's just fix that. A should be left. D should be right. And S should be down. Okay. So let's quickly run this. I could see a sparse array if you can do that in Rust. Yeah, or like a hash map, which is like close, but not quite. So here I can move these guys. I can start a game. And I can move around, which is pretty sick. And now I just have to move and shoot. And I guess we're probably playing at that point. You know, I guess do I need jump? How do I get around here? Probably not. I guess there was no jump in Doom. I'm surprised that this is working this well already. Okay. So I guess we'll just add shoot. And is that all we need? Use as well. Okay, so for use, we'll use E. So where's E on here? I guess it is probably fast. Like, it could actually be faster for me to just press the buttons A. Especially if that top bit is state, then that could just be masked and the rest could be mapped. Yeah, that seems reasonable. I guess we can check. So maybe we could try it. So these are definitely all just setting the top bit for sure. So maybe we will do that. We'll say here are our down keys. We'll check our E down as well. E pressed. Oh fuck. E pressed in scan code set 1 is, oh, that's escape. E pressed 0x12. Is this. And I guess you could like do something like 0x11 W down goes to Doom key up arrow. And then we just say A, S, D. This goes to left arrow, down arrow, and right arrow. What else we have? We have E down, so we'll turn this to down. E down goes to Doom key use. And is control a composite code, or is that easy? Control pressed. Nice. 0x1D. So we'll say control down is 0x1D. And we'll map control down to Doom key fire. Okay. So maybe we'll start with that, and we'll just say into, and we'll make a hash map here. So we'll say let key mapping match on scalars got optimized the jump tail by Rusty. Yeah, I guess you could argue that like if I did like a hash map here, that is technically worse. Really, I want like indexes. Like you could make like. Yeah, it's not super trivial, eh? Where like the scan code version, I guess, is technically better. I wonder if you could let's just try something. If you define a macro that says like set key, I think you put the exclamation mark here, or maybe here. You could take in like a from expr to expr. And could you just like omit this code? So you could say like right, like sorry, let's think of this. Here we go. W down, blah, blah, blah. Oh, yeah, if that's the case, you could break into a function that just takes in the key code and returns the map keys and the match syntax. Yeah, that does just seem better, huh? Yeah, I like that. You're right. So you would just say like this turns into a let doom key is equal to match this, essentially. And we just have to do a quick little conversion here. So we say this guy goes to this. Yeah, that does seem a lot nicer. So this is match scan code. Yeah, that seems like it would work well. And then we can say pressed is equal to doom key shifted right by 8. Or scan code, sorry. Scan code shifted right by 8. And doom key is equal to doom key. Yeah, that looks a lot nicer. And what was the last one we had? 0x1c is enter. Doom key enter. What did I not match this? Oh, I just didn't have that copied in. So we can just look at doom keys.h and we can define doom key enter as 13. And we can say const enter down u8 is equal to 0x1c. Okay. Doesn't the key still need to be masked? Oh yeah, you're right. This is and 0x7f. There we go. Okay. So that looks a lot nicer. A lot nicer. And it doesn't compile, so let's just fix that real quick. So doom key equals doom key. Oh, because I've reused the... I guess we just do this. Star doom key is equal to this instead of doing like a light out like that. There we go. Does that compile? Almost. Error. Scan code shifted left by 8. Expected I32 found U8. Is scan code really a integer? It's a U8. Scan code. Oh, it's pressed an I32? Yeah, I see. As I32. We're close. We forgot to say that anything else will just map to 0 or something. And what's it bitching about now? Scan code. Attempted to shift right by 8. I32. Oh, I'm just an idiot. This should be 7. Okay, let's see if that does it. Bum, 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 bum. Okay, so looks like that's working. And I can... Oh, okay. Definitely, we're not releasing correctly. We're actually, yeah, I think our releasing is wrong. So let's just print line scan code and pressed. Like this, and let's just double check that we're not like heavily fucking up. Oh, I've just got my pressed inverted. This should be, I guess we just do 1 minus this. And that will fix it. I think. We'll see. Okay, so we start game. I press forward, backwards, right, left, shoot. How come shooting isn't doing anything? Okay, did I get use? Is this a door? Yeah, that's a door. I can open the door. So I just can't shoot, which is kind of weird. Oh, okay. So on my keyboard, I've got caps lock and control swapped. And so it looks like the VM is actually using the real control instead of the swapped version of control. So I should be seeing that coming. And can I like play the game? Shoot, 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 shoot. Okay. Cool. And I guess, shockingly, that's it? Like, are we done? I really thought that this would be harder than that. Which is kind of... Holy shit, how much health does that thing have? I guess we don't have escape yet, so we'll just map that one as well. Music now? Shit. Okay, so we're far from that. I have, like, no audio driver. But you're right, I should get that. I can't really consider this done until that point. So maybe that's what's up next. I haven't really decided. So there's a good chance that we'll come back to it with music. I guess what I wanted to do is mouse. So I guess let's just map in the escape key now, just to make sure, like, just to say that we've kind of got everything. So escape was 27. Oh, we have that already. Doom-driven development. I like it. So key escape down. We'll make this Doom key escape. This meme is taking a lot of time. Hey, this is the life, man. This is how you do it. You let yourself get distracted and then just go down the rabbit hole forever. 0x81 is escape. So escape down. What did I say it was? I already forgot. 0x76. And we'll go run, just double check. DDD after NNN. Doom-driven development after... I don't know what the ends are. I can't figure it out. Oh no, I'm getting 1. I must have been on the wrong table. So this is 1. Give it a sec. Alright, new game. Hit escape to get the menu back up. Sick. Okay, so I think that we can call that basically done. And we can say that the next thing to do is mouse support. So we support kind of in our kernel mouse. We'd have to enable a bunch of code to get back to the point where our USB system is running. But like theoretically, we do have support for the mouse. Doom doesn't. Well, sorry, Doom does in some engines, but it looks like they kind of comment that out here. So if you go to input, they have like the engine has support for like mouse movement with relative movements like this, but the conversion code for Doom generic does not. So I guess what we could do is we could either implement a new function that's like dg get mouse, or we could do something, we could like hack in a type of key output that's like mapped to mouse movement. But I guess like if we want sensitivity of the mouse, we need more outputs than just the key. So probably like a new function makes a lot of sense. Level stuff content, majority now are just running games like Godot. Was it in search for some level fun? What are you guys doing around here usually? Yeah, okay, so we've kind of gone through start to end. We started from nothing, and now we're at the point where we have like an operating system that like boots and runs. Well, I should say a kernel more that boots and runs. It has like a web server and like keyboard, mouse drivers, graphics to some extent. And now we're trying to say, hey, let's get Doom running because this guy on the internet said I couldn't. Well, he didn't even say that. He said, do you? And I'm like, I take offense to that. So that's what we're doing now is we're like injecting Doom into our operating system and seeing what we can get going. Yeah. So next up, mouse. Let's do that. So I guess, yeah, well, let's start by trying to get the mouse subsystem up and running. So before what we had was we had this like demo function that spawned like all this async shit. And then ran this like executor that ran all of the shit in our kernel. Then what's like, we commented all this out to get Doom generic running on our like single core. And so like either what we could try to do is we could try to convert this like Doom generic loop into something that's async compatible, which seems like it should be possible to do, right? Because like Doom generic tick is like, give me one frame, and then all we'd have to do is like wait after that frame using a like async sleep, or we could just let the Doom generic code run on one core, never return from the future, and just run everything else on the other core. So let's look at like Doom generic tick and see where that comes from. Sorry, it's Doom generic tick. And he returns nothing. It would be nice if we could like find out how long to sleep, because like who's calling? There's also like a sleep implementation that we're supposed to provide back to Doom generic. DG sleep something. What was it called? It was called sleep ms. So let's see like who calls that, and if we can like pull that out to the top level essentially. So he has just a timer function is the only place that's used, it looks like. But this guy must be called all over the place, maybe. I sleep. Okay, so he's called block until start. What's this? Display. What happens in like the tick, I guess? I want to know like Doom generic tick. What does he do? He starts the frame, tries to run tick, then runs display. Okay. With next frame with current slate. So who decides when we should wait between frames? Because I'm assuming that frames don't have to be drawn. I'm assuming that there's this like running at a frame rate, but I guess that's like a pretty crazy assumption, right? I'm assuming that the game engine is targeting 60 frames per second or something, but maybe it's just rendering like as fast as it fucking can. That seems also possible. What happens in try run ticks? Oops. Try run ticks. Wrong thing here. In the Doom loop. So he checks the time. Jeez. Okay. Interesting. I'm guessing monolithic kernel. Yeah, it's all happening in one binary right now. I guess what we could do is we could count how many times we do this, and see if they're sleeping. Because it does look like the I sleep function is not really being called with like a variable time trying to get a certain frame rate. So it does seem like we could put a like targeted frame rate here and sleep in between frames. Which could be maybe a little bit interesting. So let's see what our like current FPS is. So I guess we'll say let frame counter is equal to 0. Here we'll increment the frame counter every once in a while. And after every some amount of time, we should find out if that's good or not. So we can say let kernel is equal to our static kernel. We lock it because it's in static namespace. Blech. And we say let kernel is equal to kernel get mute. And we can look at the time in here. So we can say kernel mono time. What's it called? What is this type? This is a option mute kernel. So we just unwrap. We have kernel monotonic time. And we can get time. And we can say let mute last FPS print was at 0. And we can say we want to print the frame rate every second, I guess. So we can say let FPS, let num ticks per second is equal to kernel monotonic time tick frequency, which is number of ticks per second. And so we just say if let now is this, and we say if now is greater than last FPS print plus num ticks per second, print line FPS is equal to approximately frame counter. This is like we're skipping some details where, you know, maybe this took too long and that's not fair. But we'll just print it like this and assume that we're doing it close enough. And then we'll say frame counter is equal to 0, reset it, and last FPS print is equal to now. Okay, so now that'll give us a clue, oopsies, for if we can like handle a frame rate cap externally in this loop. This should be as I32. Let's give a quick look. Still is mad at me. What's he bitching about? Expected 0, found usize. Yeah, that makes sense. So last FPS print. This should be as usize, I guess. And I think then everybody else, all the types work out. Yeah, nice. Nice. So we give it a sec to get moving. And we're running at like 45 frames per second. I wonder if I run in release mode, if we're gonna start getting a lot faster, because there's a good chance that we're losing a lot of time in these like frame buffer copies. We also haven't optimized the Doom source code at all. I think the compiler flags that we're sending just have no optimizations on, so we should probably fix that as well. Let's just take a quick look. Yeah, it does look like there's no real cap. It's also kind of funny that the maximum frame rate we can run here is 70 frames per second. That's crazy. But let's try turning on optimizations for the Doom code. So somewhere in here, we can just say like opt level 2. And let's see if that fixes anything. Actually, sorry, I shouldn't say fix. Let's see if that makes it go faster. I guess there's a chance that we start like crashing again because we start calling different functions because of the optimizer. But we'll see. Is my CPU just like fucking railed, or is this really? Yeah, it is. Interesting. So I guess that's just like the max that I can play at. And I guess if we wanted to limit this to 30 FPS, we could just in here, we could like halt until we get to the right time. So we could say like let target end is equal to num ticks per second. Let's see, we were trying to go from like 0.3033 for 30 FPS times, this is in seconds, times 6 per second, gives us like a number of ticks, plus now. Okay, and we can just say, we'll say that like let mute last frame is equal to 0. And we can say if now is greater than target and last frame equals now. No, we just want a while loop here. We want to say while now is less than target end. Halt. Or arch ASM halt. I think that should limit us down to 30 FPS. I think. There's a good chance that I fucked something up there, but let's see. Oh, now needs to be updated? That's a really good call. That's a really good call. Let's give it a sec. Boop, bump, 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 bump. All right. So that, okay, all of this is to say, uh, all of this is to say that it looks like we could integrate this with async code pretty easily, right? Because my concern was if we made this like, if we made the doom loop async, the way that our like multi-processing works right now is it uses like the Rust async await. Is there like, anyways, the point is it's called like cooperative multitasking. And so like each chunk of work, he doesn't do anything, or he doesn't let go until he's like decided that he's got a point to let go. And so if we were to just like say loop doom generic tick, we would never release the executor. And so like if we're in like, you know, if we have like 8 cores, that's fine. But if we have 1 core, that means that like the doom thing will block everything that happens forever. But it looks like since we don't have like the frame rate handling can be done by us, we can just say, oh, we'll async sleep. So whenever we're waiting for the next frame to happen, we'll just like say, okay, you can go do something else now, which is pretty sick. Which means that we can actually integrate this into our like normal kernel demo, which will make everything else a lot easier. Yeah, let's do that. So the only problem here is that we have like put our kernel in this like static namespace and locked him with a spin lock. But that's clearly going to be a problem if we're running our kernel demo, which would also need to lock that lock. So I think what we'll just do is we'll just not do that. I'm pretty sure that we can get away with that. So instead of this like once cell that we're using to create the kernel, we can just use an unsafe cell here instead because I don't, you know, it might not be right, but it'll work. And so then we can just say that the initial state is maybe like, we'll say it's an option kernel so that we can assign it to none initially. I think I do this, unsafe cell new none. Damn, I know Rust is rising in popularity, but hardcore guys like you adopting it gets me wondering. I was really in doubt of using C++ for future OpenGL related projects. Should I really switch to Rust? ML engineer here, haven't used C++ since college. Okay, so my take on this. I think Rust is for like a pretty specific subset of people. I think that if you're somebody who's like pretty, you know, if you're like, especially if you're in ML and you're like coming from Python land, Python's kind of like do whatever the fuck you feel like, and if it works, and that's great. And C I think is a lot closer to that, except that C kind of lacks the like library support that Python has, right? Python, if you want to do something, you can like just like pip install whatever the fuck, and like it already exists. Rust, I feel like, is for like, how do you call it? Like, how do I explain this? Like purists almost, like people who really, really want like almost like meant like to the point of like OCD, like correct APIs, right? Like if you're the type of person who's going to spend like a lot of time designing like a class for something and you want like the API to be perfect, right? Rust is like really like facilitates that type of user in that like you have like, because of the way that the language forces you to write code, you almost have to like overanalyze and create really strict APIs. Which means that like once those APIs are created, it's often like very nice to use. And like then you get into this state where you're like, oh, now that the type system has like perfectly told me what I want to do, like you can write code that like almost like writes itself to the state. Like, right, you just like kind of like do what the types tell you to do. And then you get to the end, you have like this like perfectly handled error code base. But I would say that, like if you're trying to like get shit done, and you just want to like prototype something and bang something out, which is like pretty common in Python land, you might get frustrated by Rust's like it tries to force you to handle all cases and force you to like think about things. And often you don't want to get bogged down by those details, and you're just like, fuck off, just let me do what I want, and like let it crash, let it be wrong. And so I think it's like hard to write wrong Rust code. Like you have to go out of your way to do it, I guess. Or I shouldn't say that. It's the code will I've let's just say that in Rust often I spend a lot more time up front writing something and then have it work the first time versus in like C++ where you like write something, you bang it out quick, and then you have to like handle all of these like edge crash cases. So it just depends on what you like. Rust is like Haskell, but it really works. I've never written Haskell, but that makes sense to me. I agree with that. Okay. And so, well, what I've been doing when I'm writing it for the kernel is I've kind of just been like, you'll see a lot of me just typing unsafe and like breaking Rust guarantees to get to bang something out. But that's not normal. People don't do that very often. Yeah. Okay, so we're back here. I'm trying to make my unsafe cell kernel because I want to just like initialize it once and then be guaranteed that it's initialized for the rest of time. Maybe I can do like maybe uninit might make more sense. And then I can put in maybe uninit. And then everywhere where I was like locking the kernel before, I'm gonna have to like rewrite that code. So let's just look for errors. And holy shit, these warnings are starting to really bother me. So I might actually fix that because I want to actually see my errors. So I wonder if there's like a way to just GCC disable all warnings. Just for now. -w is minor w. So in my build script, I can go and say flag -w. And hopefully that'll do it. The Winit WebGPU general GUI ecosystem in Rust is getting really neat. While a lot of the GUI frameworks are still young, their portability is outstanding, mostly built everywhere, minimal effort. Yeah, it's pretty. I will say that like writing a like UI in something like Rust and eGUI is so much nicer than trying to write something in like C++ and Qt. There are again trade-offs, but yeah, there is something that's really sick about like the forced immediate mode GUI paradigm. Yeah, it feels good. And I'll say that in C++ with Qt, like if I'm writing like Qt C++, when something doesn't work or the way I want, it's like a massive pain in the ass. Where with the young GUI frameworks, it's kind of nice where that like when something doesn't work, it's really easy to just bang out your own widget, which I found a lot harder in like other languages. Okay, what doesn't he like? Cannot find the type maybe on init, so let's just import that. So I think that's from core, maybe core. I don't know where that's from actually. Maybe on init in Rust. Core mem. Okay. This cannot be shared between threads. Oh, that's annoying. So I guess we'll just wrap this in a type that can be. So we'll say pub struct static kernel is just this thing. And we'll just mark it as sync. So we'll say unsafe impl sync for static kernel. And that's probably fine. And then here I'll just make this a static kernel. And this is static kernel unsafe cell, maybe on init. Oh, there we go. Okay, so now he's getting a bit mad because before we had this mutex locked, and we don't want to do that anymore. So I think we can just say, let's make like a function on this to make it easier. And maybe we can, oh yeah, we'll just say impl static kernel, and we'll say function get takes in self by mutable reference and returns a reference to a kernel. And all we have to do here is do self.0.get, and then we star it, and assume init. And this all is unsafe. All right. Okay, so what did we just, like, what the fuck did I just type here? This self.0.get will return a pointer to a maybe on init, and then I dereference that and assume init and get back the kernel. Does Rust have async prog? Rust has, like, an async keyword that lets you, like, construct functions that will automatically generate like yield points, like similar to like Python generators or something like that. And then they have like these runtimes that you can use to like move those pieces of work forward. So like, yeah, it does have some form of like async. But I don't know. It depends on what you mean by async. It's not as simple as like in JavaScript if you just type like await. It's a little bit more complicated than that, but not by much. Okay. So now all these places where we're locking the kernel, we can say kernel.get. And we can do the same thing here, kernel.get. And here we can say kernel get. This guy should actually return. Why does this guy have to be mutable? Does he have to? We'll see. We have to do this it ourselves, so we'll come back to this. And this is kernel get. This doesn't like that it's a reference to temporary value. So can I like let kernel is equal to, or let maybe uninit kernel is star self.0.get. And then can I do this like assume init? No, cannot move out of raw pointer. So I need to borrow here, I guess. And probably I need like an assume init ref or something. Yeah. Assume init ref. Okay. And so now he's complaining that the kernel cannot be borrowed as mutable. And so this is like probably a problem. So I guess what we'll do is we'll just make our PS2 keyboard. We'll like put him behind a mutex or something so that I can read him without having to get a mutable kernel, because we're going to have multiple people trying to use the kernel at the same time. Which is annoying. So I guess here we will say mutex PS2 keyboard. And that's fine, and we'll just lock them up here. So here when we have PS2, this is now needs to be mutex locked. So we write mutex new. And here we have this like we had our Brick Breaker game that we were working with before, and I'm just going to comment out the whole Brick Breaker game. We don't need him, which makes this whole thing simpler. No method read for this guy, so we have to say let PS2 is kernel PS2 lock, and this is the PS2 read, and this has to be mutable, and awaiting the future and calling output await. So I think that's fine. That's just warnings that we can probably ignore. Oh fuck. Sorry, I was supposed to lock this mutex from an async context, but we're not in an async context. We're in a synchronized context, so we'll use a spin lock here instead, which will just make this easier for now, even though it's not the way I would want this organized later. Okay, so I think we're back to compiling, which is pretty cool. Pretty cool. And so now we can probably start integrating our game here. So we can make our doom loop. Let doom is an async block. And he's basically just going to call... Where is my doom stuff? Doom, DG... Where is all this stuff? Here. Here we go. He's going to call doom generic create. And he's going to have a loop where he does a tick. And we'll just say let start is equal to self dot time now, or get, I guess. And we'll say let end is equal to start plus 0.3033 times for 33 milliseconds for 30 frames per second times the monotonic time tick frequency, and this should be factored out. We only want to call this once, so we'll say here let frame time is equal to this start, and so the end should be start plus frame time, and then we say sleep for I guess sleep is in seconds. So we actually need to check how long we've spent, which is different. So let's say tick freak is this guy. And instead we want to do let end is self monotonic time get. And here we have to convert that into a sleep time. So we'll say 0.033 minus end minus start times, or divided by the tick freak. And I'm pretty sure that's right. So we can actually do a 1.0 over this now, and then do a multiplication, which I think is faster, if I remember correctly. And we just say this is as f32, and then we can do a create sleep for this amount of time, but passing in a reference to self.monotonic time and self.wakeup requester. And then we wait this, and we should have like an async sleep in here now, which is pretty sick. And then all we have to do is throw in a spawn to doom. Cool. Why is that still there? Okay. And so now I think all we have to do, all we're missing now is initialization of our kernel with our new thing. So we'll just say kernel 0 get, which gives us a star to maybe an init, and we'll just say write. And here we pass in the initialized kernel, I guess. He doesn't like that, so let's see what he's bitching about. He expects maybe an init kernel. How do I, like, set this guy? Maybe an init. Oh, I say maybe an init new. I see. So I say this guy is equal to maybe on init new, and then I pass in the kernel. I don't know if anybody in the kernel is expecting to have like stable memory addresses, so this might actually start fucking shit up, but we'll find out. Let's try running our demo and just see what happens. So here we can say kernel.get.demo. And I guess our demo takes in mute self, so that's going to be a pain in the ass. I guess this guy also has to be immutable reference to self, which is going to fuck up all of this. That's so annoying. Ugh. Okay, well, what we'll do now is we're just going to lie. We're just going to lie and say that this returns a mute kernel. And that's maybe going to cause a problem, but that's okay. We'll see. Mutable borrow from immutable input. Why? It doesn't like that? Interesting. I thought that would be allowed. Is it because like the lifetimes are tied together? If I say like dash A and dash B, can I say these are separate things? Don't worry about it. I can. All right. Let's take a look. I wonder if this is gonna like run at all. I guess we'll find out. So we're booting. Nothing's happening. Oh, okay. So the Doom stuff is running. And is my web server running? Oh yeah, all this other stuff is running too, which is interesting. So here, if I like go to my web server now on this guy, is he running? Oh, that's pretty cool. Okay, so I think we're in a state now where Doom is running from our like async context, which means that now if I start like moving the mouse around, we should actually be able to like get that piece of information. So in our cursor service, maybe I can just write down position is position. And I guess we can actually start using like info logs and stuff too here. Taking a look. And so maybe now if I start like wiggling my cursor around, we'll start to see movement on it. Sick. Okay, so we've got Doom running and we have mouse movement, which is sick. I guess technically we don't want to use the cursor here. We actually probably want the, we only care about the relative movement, which comes from the mouse driver. So in our Doom kernel, or not our Doom section, we're gonna want to like somehow retrieve updates from the mouse. Okay. Let's think about this. I guess like in theory, you could get around some of this like bullshit of like this kernel having to be in static memory by making like static channels that you push to and that the Doom function's read from. Then you could handle everything like in normal async code from the kernel. But we can skip that for now. But like I think that like probably what I would do if I were to like try to do this for real is in my like mouse code, I would like push to some queue that the Doom callbacks read from, and then I wouldn't have to have this kernel in static memory. But I guess eventually the kernel will probably have to be in static memory anyways, because eventually if we do like user space to kernel space, I think that those are all like parameterless, like syscalls. We would have to have like a static reference to the kernel anyways. So I don't know, stuff to think about for the future. But for now, all we want to do is we want to look at our mouse stuff. So where does that come from? We have like a USB service somewhere. We have a mouse movement writer. And so I guess we almost certainly have a mouse movement reader as well. Where does this mouse move tx get used? Ah, nice. Okay. So when we construct our mouse, we give it a channel just to, like write movements into. And we can say we can just, instead of trying to like pass the mouse movements to the cursor, which is like a absolute position thing, we can say let mouse move tx mouse move rx is equal to what? Just like a channel. What does our mouse drivers expect? Our mouse driver tries to send things to an async channel. Yeah, so this is just async channel. And now the question is, how do we like get the reader side into Rust? Straightforward. Do you know how Fuchsia OS works on syscalls? No, I've actually never looked at Fuchsia OS at all. What is it? That's like Google's OS, right? Fuschia OS. You used to work on Fuchsia. Oh, that's pretty cool. Was it fun? Well, how does it look? Fuchsia syscalls. Oh, did I get it wrong? F-U-C-H-S-F. Fuck. Huh. All right. Future export a huge VDSO like the Linux one, and you get sys cluster. Dude, I was actually thinking about that the other day. I was thinking that's how I would want to do it. That's so sick. Is performance better when you do it that way? I imagined it would be. But I like that. That's actually so cool. That's like, I was thinking about that exact thing. That's pretty sick. Okay. Getting distracted though. So we want to somehow pass this channel around to these like callbacks that have no parameters with them. Oh, so we could probably just like put them in like a static variable somewhere for now. So we have dg get key. Or I guess since we're injecting the mouse movement, we can do whatever the fuck we feel like. And so what I feel like doing is I feel like not doing it with these callbacks. I feel like injecting it directly into the Doom code. So what we can do is in our Doom stuff. How would I handle this? So in here we have Doom somewhere. Let Doom is equal to this. And here we could like pull the mouse movements. We could just say while movement is equal to mouse move rx dot. What does this guy have on him? I'm sure he has like a non or a synchronous read, but let's just see. Receiver. He does not, but we can just add one. We can just add a function try receive that takes an option that returns an option, and we can lock the thing inside. Oh, this still needs to be an async function because the mutex is async. And what does this guy do? We can just lock and then pop from the inner thing. So this inner has a vec dequeue, so we can just say queue pop front. Cool. Cool. Which means here we can just say loop and try to pull a mouse movement. Mouse move rx is defined below, so we'll just kind of swap these guys here. And we say match let movement is equal to match movement. If it's something, we can propagate, and if it's none, we break. And then all we have to do here is like doom generic, and we have to write a function that will like move the mouse. But that should be pretty easy. Should be pretty easy. Where is this bitching about me? He doesn't like that. Oh, it's util async channel. There you go. Here I forgot to await, which is fine. Let's do that real quick. And there we go. Yeah, the biggest thing with the VDSO's compatibility is if you decide you want to rework the syscall ABI, you can just shim whatever you need into version VDSO. Oh, that's pretty cool. So you like your kernel keeps all of the VDSOs forever. Like in the same way that when you update GCC, you have like versioned symbols for each libc call. You just do the same thing with the VDSO. So you just like keep the old ABI around in case people linked with it, and then update and have the new one. Cool. Okay, so I'm gonna look at this movement, and I'm gonna have to find a way to inject it in. So in Doom generic, I can just go to the input.c, and somewhere we could just call like void dg insert or Doom generic push mouse. And then all we have to do is run this stuff. And so we just need to figure out what these like inputs are going to be. So we're going to have xrel as a float probably, and yrel as a float. And is that really it? I guess we just define an event somewhere. So here we need event t event. And I wonder if that's it. I guess here we just replace this with xrel and yrel. And then all we have to do here is we say doom generic push mouse, and we pass in the movement.x and movement.y. And I bet you that's pretty close to working. So we'll just make our doom generic push mouse function definition here. And we're going to have the x is an F32 and y is an F32. And I wonder if that'll work. It seems possible. It also seems like it might not work, but we'll see. Okay, so mouse button state, he didn't like that. So we'll just put that as 0. Because we're not handling the buttons, we're just handling the movement. So here he doesn't like the type here. He says type has to be known. How is that not known? 502. Yeah, this should just be a movement, right? Like cursor movement. So what's the problem? Weird. I don't understand why the type resolution wouldn't handle that for me. So he's saying doom generic push out undefined reference to accelerate mouse. Oh, interesting. Okay, so that function just was commented out here but doesn't exist. So I guess we have to look for EV mouse and see who uses that guy and see what the like what that should be. So this is data 2, mouse X, mouse Y. It just looks like it's like movement. So I guess I just don't have to handle. I can just punch these guys in directly and see what they look like. Zombie code, yeah. Bump, 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 bump. All right, so we compile, we run, and I guess I will start a game and see if when I rotate my guy's mouse, I'm seeing nothing happen. So what we should probably do is we can maybe check that we're pushing mouse movements. So we'll say here, info pushing mouse movement, and we'll say the movement, because there's a good chance that I fucked that up. And I guess this shouldn't be a cursor movement, actually. Oh wait, maybe it should. Cursor movement. Yeah, that seems reasonable. It's relative x, relative y. And he can't be printed, so let's just quickly throw a debug thing on him. Take a quick look. Okay, and I guess I have to wait here. Okay, so I am pushing mouse movements, but I wonder if they're just super, super small. So I wonder if I like pay a lot of attention, I just move this a lot. No, it does seem like that's doing like literally nothing. I wonder if I need to enable mouse movement. No? Okay. So I wonder. Let's look at d post event. Or I guess where did I say that? I saw the EV mouse. Yeah, what range does it want? Yeah, we have all sorts of questions that we want to answer here. So let's make sure that we're setting this at all. So we'll say printf handling mouse movement. And we'll say that we got these movements from EV data 2 and EV data 3. First of all, what is the type of EV data, right? Like, if I'm assigning floats to this, is that what they want? So where is EV data 2? EV, oh, sorry, it's data 2 is what it's called. And do you think it's a float, maybe? Int? This has got to be like in a structure somewhere. Where, I guess this is, we can look at the type of event. Event is a struct event. Event T. Where does this event T come from? Here we go. So these are ints. So the fact that I'm casting my normalized 0 to 1 float to an int is almost certainly fucked, right? So probably I just need to like multiply this by a lot. Like a lot. So somewhere where I push these, can I just like times 100? Bum, 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 bum. Yeah, maybe it's the screen space or something. It's common to use pixel counts or some such. Interesting. I wouldn't have expected that. But we will find out. So here, unhandled to size in handling mouse movement percent. Oh, fuck. Oops. I tried to print the movement, and we just don't support floats in our printf implementation, so it just immediately crashed. Fuck. That's pretty funny. That's funny. So let's just... Whoop. Also, they weren't floats, so it was just like fucking wrong in a bunch of ways. Okay. So let's try again. Oh! Oh, sick! Okay, so it's very fucked still. 100 wasn't enough. But that's definitely doing something. And the suggestion that it's in screen space seems pretty reasonable. So it'd be kind of interesting to try multiplying by 640 and 480. Just to see if the movement is more reasonable. And we give it a sec to boot up. Alright. It feels like we're missing movements. Which is interesting. Let's crank this up a little bit. Yeah, it does feel like when I push multiple per frame, it actually doesn't like that. Right, like I can see like jerkiness in the motion, which is kind of odd. But let's try FPS cap. Oh, like maybe I'm missing. But like all of these things should be coming into a queue, and we should be pushing like the addition like of all of them together. That's kind of what I was assuming would happen, right? Because like we have like a queue of things that come in, and I don't think we're hitting the end of our queue. Maybe we are. Yeah, that does seem possible. Maybe we're just getting too many motions per frame, and we're like running out, and we're not logging if we run out. Oh no, maybe that's okay. It could just be that 1,000, like the units are really low. That doesn't feel so bad. Let me try maybe disabling all these prints. They might be making things slower. So pushing mouse movement. Let's just kind of get this guy away. And let's just double check. Is there anything else I wanted to look at? I wanted to see if we what happens when we push and we don't have anything. So let's look at the mouse driver here. And he pushes to this pause tx, who is a sender, who is backed by a vecdq. So we should just grow this infinitely until we run out of memory. So I don't think I'm really worried about losing events, but maybe on the Doom generic side, that's possible. So what we could do is we could send one movement and add them all up. That seems kind of reasonable. So we could, just in case like on the other side there's a cap for how many events that they can take at once, we can convert this into one massive event. So we can say, let movement, oopsies, this guy is going to be mutable, and he's going to be a cursor movement x 0.0, y 0.0, and we'll just accumulate these. So we'll say movement.x plus equals, let this movement, I guess we'll call it, and we'll say movement.x plus equals this movement.x. So he doesn't like something here, because this should say this. And then before we tick, we'll just push one movement. Okay. Let's see if that feels any smoother. Oh yeah, that feels pretty good. That feels really good. That's sick. That's so cool. Okay. Well, that's super sick. I guess, oh, okay. Well, I can't call it a day until I set up strafing to work correctly. So we'll do that really quick here. Did I resolve the tearing? The tearing was coming, I think if you're talking about like from last stream or from earlier today, were you here earlier? Yeah, you were. Oh, tearing is Cumin not doing vsync. I actually don't see tearing for me. So, unless I'm just not noticing it, I'm usually pretty upset by that stuff. So I think I noticed, but I'll double check next time we booted. But I would guess that that's a artifact of something else, but I'll double check. Okay, so what was I trying to do? I was trying to make A and D strafe instead of turn. So that would be in DG get key, which is implemented here. We just need to change these mapping to do strafes instead of turns. So here we'll say A is strafe left and right is strafe right. And we'll run it one more time. And I think that will feel pretty damn good. Let's see. Oh, baby. Oh, yeah. Oh, yeah. And I guess since somebody was complaining that there's no music, we can just go pow pow. That's sick. All right. I'm pretty happy with that. I think that we've got like, that's super playable. That's super cool. I'm pretty happy with that. Okay. Thanks for watching. Yeah, if you like what you saw, I stream most days between 1 and 2 o'clock Pacific time, for around 1 or 2 hours. I'm not sure what's gonna happen next. Probably, I think I'm probably gonna take a day off tomorrow and come back the day after. And I think probably the next thing I want to work on is, I did want to start trying to like boot in other virtual machines, so I might work on that. I've also been thinking about like file system support in terms of like dog fooding. It would be kind of cool if I had a file system. I could probably run like a real web server on this thing and like use it for some of my like little local daemons that I run to do shit, and that would be kind of fun because then I could start dog fooding and see, you know, start finding real bugs. Yeah, I'm not really sure. So we'll see. The Doom saga, I think I'm going to call this done, right? And I don't know if I'm going to, I don't know how much of this I'm going to try to salvage into real code. I took a lot of shortcuts in terms of like the libc implementation, so I'll probably keep the branch around just to like reference for later, but I don't know if I'll like commit any of that to the master branch. Yeah, okay. So we'll be back in a couple days. Thanks for watching. If you're watching on Twitch and you missed stuff, there's a YouTube link in the Twitch description. If you're watching on YouTube and you want to come by, say hi, chat, whatever, there's a Twitch link in the YouTube description. People in chat seem to be asking about Discord, so I don't have one, but I guess it's probably worth trying to set one up, so I'll try to work on that soon. Yeah, thanks for watching. Catch you guys in the next one. Bye!